All right. We'll get moving with this. So just to introduce myself, my name is Liam Gensel. I'm a full stack software engineer, primarily a lot more on the backend side of things, and a lot of the stuff I do is working on REST APIs in Python, specifically Django, and I thought it'd be very fun to do a workshop on FastAPI, which is something I've started to play around with in my free time, and I thought it was pretty cool, and I just wanted to show some more people. So this is the Bootstrapping with React and FastAPI workshop. So it's going to be a two-part workshop, and this is specifically the backend. So my friend Ryan is doing the front end workshop tomorrow with React and hooking the rest of it up. So we're going to be building a quiz application, so you can create quizzes and take them and delete them and all that fun stuff. So this is going to be pretty high level, and it's going to cover like a lot of stuff, like just from like what an API is to like touching what even what a database is, and then just scraping the surface of a lot of stuff. So I don't want to waste anyone's time. So if this is like something you feel like you're not getting anything out of, like, feel free to drop off the call. No worries, no hard feelings. So, all right, let's get rolling. If you have any questions, feel free to just unmute yourself like at any point and interrupt me. That's fine. I'll answer. So, yeah, to get started. So, what's an API? So, an API just stands for Application Programming Interface. So it's just a way to interact with like an application or piece of software programmatically. A big misconception is a lot of people assume that APIs are just on the web, but that's like not the case. It's just a way to interact with a piece of software in general. So like a lot of language libraries are APIs. So like FastAPI itself is a Python library. So in itself is an API, right? But we also have Restful APIs, and these are APIs that are actually accessed over the web. So REST just stands for representational state transfer. So you interact with this API over HTTP, and HTTP has multiple different verbs associated with it. Just to name a bunch, you get, post, put, delete, head, connect, options, trace, patch. The ones that we really care about, though, specifically for building out a REST API, is get, post, put, and delete. And this is like the basic idea behind like the REST API, right? So a client would make an HTTP request, specifically in this scenario, it's a post to some resource on the server, the API itself, and it'll respond with some data. So you do that to different URLs, right? Different endpoints. Okay, so the idea behind like a RESTful API, it's got this like Crud architecture, which just stands for create, read, update, delete. So all of those different verbs basically describe different actions that you'd want to do. So the idea is you want to keep it pretty simple, where you just create data, you read data, you update, and you delete it. And these are just the mapping of the different verbs to the action with CRUD. So one more thing before we get kind of jumping into FastAPI and actually starting to write some code. If you're unfamiliar with JSON, it just stands for JavaScript Object Notation. It's just a file format that's like become a standard for transmitting data over the web. There's other ones as well. There's like XML and a handful of other stuff, but I don't have actual numbers, but I'm assuming that JSON is like one of the most popular. I've seen it everywhere. XML is more rare in some more legacy systems. So, all right. So FastAPI itself is it's a Python web framework for building APIs. So coming from doing a lot of Flask, which is a super small like micro web framework, and coming from Django, which is like way heavier weight and has a lot of features. I feel like it's a very nice mix between the two. You get like a lot of the flexibility that you do with Flask, but you also get like a lot of out of the box features that you get with Django. And specifically, the stuff that I like the most, you get Swagger docs that are automatically generated. A lot of data validation stuff built in, security and auth, dependency injection, WebSockets, and like GraphQL support. The two things that we're going to be talking about mostly today are the Swagger docs and the validation. So let's start by just writing some code and building a basic FastAPI. So for those of you who followed along with the doc I sent out last night, great. If you didn't, or you had some trouble setting some stuff up, some of this stuff might not run for you. That's okay. Just try to follow along and get some stuff out of this. So to start, I'm just going to go over. I went into the Buffalo Quiz app repository I had everyone install, and just went into the server folder, and I activated my Python virtual environment and did all the installs and everything. So what I'm going to do is I'm just going to create a new file called app.py. And we're just going to open that up in our text editor here. And it's very, very simple to start. So all we need to start with is importing FastAPI. So from FastAPI, you just import FastAPI. And then from there, you're going to want to initialize the app. So you can call this whatever you want, but the standard is just app. And you just initialize the FastAPI object here. And then what you'll want to do is you'll need to start specifying some routes so that when you start hitting different URLs on the server, it knows what to execute, right? So we can start with like a very basic, just like home route, right? So we can start by just writing a basic Python function that just returns like hello world, right? Basic enough. But there's no way for us to know, like, or for the server to know, all right, well, if I hit like /home, how do I know to execute this piece of code? So we can just add an annotation to the function. So you just do @ and then whatever the app or whatever you named it here. So in this scenario, we did app dot, and then you can do whatever HTTP verb you want to specify for this function. So if we wanted to do post, we could do .post, we could do .put, whatever. In this case, we're just going to do a basic get. So that's all it is. And then inside of parentheses, you just, or inside of a string inside of there, you just put in whatever route you want to go to. So in this scenario, we'll just do /home. And that's pretty much it. Like that will run a very, very basic API server. So to actually run it, we're going to use Hypercorn, which is just an ASGI server. And I'm not going to get too much into that, but assuming you install all the requirements, you should be able to run Hypercorn. And then you'll want to specify the app. So first is the file name. So in this case, it's app.py. So we'll just do app : and then whatever the variable name you made the application here, which we made app right here. So it's actually going to be app : app. And then you're going to bind it to, with -b, to just a port on your local machine. So it'll know to run there. And then we can add a flag called reload, which just does hot reloading. So anytime there are file changes made, it'll restart the server, and those will take effect. So if we run that, you'll see we have our server running on our local host. And to show you that, if we pop over here to localhost port 8000, like I said, there are Swagger docs that are automatically generated, and those go to the /docs URL. So if we go to /docs, you'll see our FastAPI docs are here, and the route that we had /home is here as well. with some basic stuff. And you should have also installed Postman. So in Postman, we can actually call that /home route. We could just make a new request, specify the verb we just want to do get. And if we run localhost port 8000 /home, it should give us that hello world response back with the 200 status code. So that's all it takes to do a very, very basic API. Let's pop back over into here and I'll show you a little bit more. So we can add some more to the documentation with just adding a doc string, just adding the line here, get the home page. And if we save that and we go back to our documentation, refresh the page, you can see our documentation was updated with what we just changed. That's the reload feature. All right, perfect. So now we'll talk a little bit about requests and response validation. So more often than not, a request and a response is going to have data in it, right? That's the whole point. And you want to have a way to like validate that data. You don't want the client sending invalid data to the server and vice versa. You want to define you want to have like a well-defined contract between both the server and the client. And a way to do that is with schemas. And the way we do it with FastAPI, bundled along with the FastAPI library is another Python library called Pydantic, which does that validation for us. So we can hop into a demo for that. So we're done with this app.py file for now, and we can kill the server that we were running. And we'll open up our main.py file. So this is just another FastAPI setup, and it has a little bit more in it. Don't worry about all this, but you can see we're importing FastAPI, we're creating it, and then we have our basic routes. So let me open up also our schemas file and just put that over here so you can see that. So if you look here at our post endpoint, this just does a post to create a quiz. And when you create a quiz, you're going to send a bunch of information. You're going to send a title and an author, and then a bunch of questions along with it. So how does our API know like what data is coming in, and how does the client know what to send? We can actually pull out the data from the body by just passing in a schema as the argument to the function for the endpoint. So you just call it whatever you want, and then using the Python type hinting, you just specify a specific Pydantic schema, which I'll show in a second. And then you'll have access to all that data. And it'll validate that when the client's making the request. So if some of that data is invalid, it'll throw an error message back, and the client will be responsible for doing that error handling. So over here, you can see we have the schema, the create quiz request schema that we're using specifically for creating a quiz. So that inherits from the quiz schema, which inherits from the base model, which we just import from Pydantic. So I made a base quiz schema so I could build some other more specific ones off of it. That's why they're separate. But at its core, it just has the attribute. So whatever the name is going to be in the JSON object and its type, and you just use the Python typing library, those standards. And then we're looking at the create quiz request. From quiz, we also have a list of questions, and that's going to be from this model here, which just has our question text, correct answer, which is just an integer for representing one of these four questions. and then the question or the answers themselves. And then obviously a question is going to have at least 2 potential answers. We could specify up to 4, but we set these to none because they're optional. And you don't have to worry about this right now. I'll get into that a little bit more later when we start talking about the ORM. But that's how the schema works here. So if you go back into Postman and we go to make a, first we should probably run the server. So I'm gonna run it same way I did before, but this time I'm just gonna change the file to main, and now it should be running. When we go back into Postman, we can make a post request to localhost port 8000/quiz, make sure it's post, and then inside of Postman, if you go to body here, and then you hit this raw option, you can change the dropdown to be JSON, and this will let us send a JSON object in the body of that request. So we'll just do a quick, we'll take a look at our schema to make sure. So it's going to have a title for workshop. We'll have an author. And then we can have a list of questions here. And that'll just be list. And we'll just have one question in for now. And we'll have to give it all of its attributes. So it has question text. And we'll just say question 1. It's fine. Nothing too crazy. And then we can specify the answers. Whatever. Answer 1. Answer 2. Answer 3. And we'll also want to specify the correct answer. That's also required. And we'll just say 2. And we're not worried about answer 4. We're going to leave that one blank since it's optional. So now if we do the post to /quiz with all of this information, we should get back a response that looks like this with the created quiz. So if we can calling it, we can just keep creating these quizzes. So there's also the response model, which is what's specifying this response that comes back. And the schemas work exactly the same, except instead of adding it as a parameter here, you just specify the keyword argument inside of these verb calls and specify the schema that we want. So in this case, we used quiz response, and our quiz response is just, again, built off the quiz, but it also uses the ID that gets generated. Again, I'll get more into the ORM mode stuff here in a little bit. But that is the schema for that. So are there any questions so far? I know I'm moving pretty quick. Oh, all right, cool. Sweet. So that is, oh, before we move on, I wanted to also show you guys, if we go to the docs, you can see the schemas get generated here. So it's really easy for like client developers to just take a look and see what the schema is. And they can take a look and they can see, okay, create quiz request, title, author, questions, these are all required. And then they can see the specific, there's sub schemas in there. They can see that. As well as they can see specifically for the endpoint, they can see the schema required. So one other thing I forgot to show you is what if we change, so like obviously this worked no problem, right? Because all of our data is correct. Like what if our data is wrong? So if I change correct answer, which is supposed to be an integer, to a string, and I send that, we'll get an error back. Comes back as a 422 status code. And And it looks a little confusing at first, but it's actually pretty clear on telling you exactly what the issue is. So it's in the body under the quiz schema, the questions here, the specific index, which is just the first one, and then the correct answer. And it's just that's the type is incorrect. Also, if you're missing a required one, same thing will happen. So it's really, really nice, and the validation kind of just works out of the box. Cool. So let's keep going. So when you're creating quizzes and you're getting all these quizzes and you're doing all this stuff with them, you need to keep the quizzes somewhere, and you could store them in memory if you wanted to, but that doesn't really make sense like long term. So you want to have some sort of persistent storage. So for those of you who don't know like what a database is, it's just a way to persistently store data. So there's like two main types of databases. You have relational and non-relational. Relational databases use like tables and rows and columns, whereas non-relational are like NoSQL use usually like JSON stores, and but we're not really worried about that. We're going to be doing relational database, specifically Postgres in this one, and it is a relational database. So the way you interact with that database is through is with SQL queries. So SQL just stands for structured query language. It's just a language to, query data, create data, specify schemas, all that. So this is just some basic syntax here, basic query. This would just select all the columns from everything from the users table, assuming there was a users table in the database, where the email column, was this specific value, and it would extract all the rows from there. So, but we're not going to write any SQL in this. We're going to use NORM, which is essentially just a wrapper for SQL. And it allows you to like model your tables through classes and objects, and do queries with just like function calls. So it's very, very nice to work with in your code. There's a lot of trade-offs to it when you're doing like more advanced queries and stuff. Since the ORM just like generates this SQL, sometimes it does not generate it well, and the queries can be like very inefficient. But the stuff we're doing is pretty basic, so we don't have to worry about that. So the ORM that we're going to use specifically is SQL Alchemy. So let's jump in, and I want to talk about the quiz app database format a little bit beforehand, so you guys get an idea of what it is. So we have two tables. We have a quizzes table as well as a questions table. And our quizzes table just contains our title and our author with a unique primary key, and that'll just be the ID, and just auto increments as you create new quizzes. And all the quizzes need questions. So we'll also have a questions table with all the same attributes that we were talking about before that was in the schema: the question text, correct answer, all the other answers. It also has its own unique ID, but it also points to the ID of the quiz with a foreign key in the quizzes table. So we know that quiz 1 contains question 1, right? Because it needs to be some way to tell. So let's jump into the actual models in the ORM and stuff. So I'll leave the schemas up for now, and let's open up our models file. So this is where we're storing all of our models. We have a bunch of different imports from SQL Alchemy. Wouldn't worry about them too much, but specifically the column, that's just going to specify the column, and then all of our types here. We're not actually using date. I imported that, but that's fine. So we have our quiz model, question model. So we'll start with the quiz model. So you have you specify the table name that you want it to use, and then you just specify all the different columns that you want. So here we have our ID, which is just an integer, and it's a primary key. And then specify the title, the author, their strings. And then I'll get to this in a second. We have our constructor here, which just will build that model as just an object. And then we'll have access to some ORM features where we can save it. And then take a look at our question one. Same setup, except here we have a quiz ID column, and that has a foreign key to the quiz table. And you don't have to worry about any of this on delete stuff. But inside of the quiz table, we'll just specify that it does have a specific relationship to the questions. So that way, when we're querying it, we can make sure we pull the right questions. So that's a quick overview of the models. So typically, when you're doing, you make model changes here or there as you're programming and building up your application. You need a way to manage those changes to the models, and you would normally do that through like a migrations framework. In this scenario, we're not going to make any changes, so we don't really need to worry about that. But if those tables don't already exist, we're just going to use this up here. So just import our models, call the base on it, which is from here, and then just do a create all. And that'll just make those tables with the correct structure if they don't already exist. All right. So if we take a look here at our get quizzes endpoint, so this endpoint just gets the list of every single quiz in our quizzes, or in our quizzes table. And the way it does that is it uses this session here, which we pull from this database file. So this sets up all of our connection with our database. You don't have to worry about too much of this. Is a lot of boilerplate stuff you can just pull right from the documentation. But the main piece that we want to worry about is session, which is that active connection to the database, and then the base, which we used for the models, and it's just the base model that we're going to build our models off of. So inside of our route for get all quizzes, we can run session.query, and that'll make that'll basically query whatever model we pass in. So we're passing in the models.quiz, which is this guy here. So we're querying on the models table, and we're just going to call .all, and that'll do a select for everything in our table, and that'll spit that back. And you're probably wondering about the response model here, or the the response model for /quizzes. That's where the ORM comes into play, this ORM mode, and that just does a lot of behind the scenes stuff. There's a lot of transformation of stuff, and this just allows it to know, okay, hey, if what gets returned here is in a dictionary, and it's an ORM object, that's fine. I just specify that so I know as I'm translating it to JSON, and that's how we get also access to the ID here. So that's all it takes to query everything. So if we wanted to query like a specific quiz, which we definitely will, right? If we're taking one quiz, we're not going to take every quiz at once. We can create an endpoint to do that. So if we made an endpoint to get the single quiz, and we did get single quiz, and we can just say it's going to be a get. And we're going to say it's going to be /quiz and then / and then inside of braces, we're actually going to write quiz ID, or this could be whatever you want to call it. But the URL that we'll end up hitting it will be /quiz / and then the integer, you know, of whatever quiz we want. So whatever that ID that gets generated is. Since it's a get, what we can do is we can pass in the quiz ID, whatever we named it here, and the type. Since it's a get, it works very, very similar to how you'd pass it in as a parameter here, except instead of pulling it out of the body of the request, it knows to pull it out of the route. So let's see. So if we're going to implement this, what we'll want to do is we'll want to say, it works pretty much the same way. We'll do session.query on the models.quiz. And then instead of saying .all, what we'll want to do is we'll want to filter that list down to just what we want. So we can get a little more specific with it. So we can say .filter, and then we can specify what we want to filter on. So specifically, we want to make sure that the ID of the quiz is equal to whatever the ID that was passed in is. So we can just say models.quiz.id is equal to the quiz ID. And then that'll return us a query set, but it won't actually give us the quiz. This is going to return, we know that it's a unique key, so there's, the only option is it doesn't exist or there's one of them. There can't be more than one quiz with the same ID. So we can just pull the first one out just like that. And that'll give us the actual quiz object. And then we can return the quiz like that. So now if we went and we to Postman and we go to call that endpoint as a get, say we want quiz 10, right? We can call that there. You can see it pulls the quiz, but the problem is there's no questions associated with this quiz, which if we're going to take one quiz, we need the questions. So what we can do is, if you look at our schemas, we have one for a single quiz response. So it's the same as the regular quiz response, except it also includes the questions. So if we specify the response model on the new endpoint we just made, we can say we want the schemas dot single quiz response like that. And that will, because we have the foreign key set up with our models and everything, and we have all the OR mode stuff set up, now when we run this, it'll throw all of our questions in there and just in one big list. Sweet. And that's all it is. So what we'll also want to do is we can't just leave it with, you know, getting quizzes and making quizzes. Like, what if we make a quiz we don't want? What we can do is create another endpoint for deleting. So we can say app.delete this time, and we can pull this guy here, and we can just say, oops. Like that. And then we'll specify the response model shortly. If we delete quiz, same way, quiz ID. And then it's going to work exactly the same way. We're going to say quiz is equal to, and then we just copy this whole line here. And oops. Cool. And then what we'll want to do is, instead of just returning the quiz, we'll actually want to delete it. So what we'll do is, with our session, we can just say .delete, pass in that quiz, and then that'll stage it essentially, And then when we run session.commit, that'll commit whatever we have staged in like one transaction. So that way we're not making, you know, a bunch of different queries at once if we had a bunch of different changes we were making. So then what we can do is we can still return that quiz because, you know, rather than just returning like null or like true or false or whatever, we can just return the data that we just deleted. Doesn't really matter, whatever you wanted to set up with your front end. And now if we run delete in Postman on that endpoint, you'll see it return to us our quiz. And if we go to here and we just do a get for all the quizzes, you can see quiz 9 and then quiz 10 no longer exists. So it's that easy to delete it. So one other thing I want to talk about is, you know, if this quiz doesn't exist, so quiz 10, right? If we go to get just specifically quiz 10, it doesn't exist. So instead of just returning null, we might want to return something like a little more informative. So we can say that basically if this comes back, it's either going to be none or the quiz object itself. So we could just say if the quiz doesn't exist, we can return. And then what we did is I imported HTTP exception from FastAPI, and I can return an HTTP exception with whatever status code I want to specify. So we'll just say it's like 400, and then whatever you know, message we want to include along with it. So you can just say you know, quiz with ID, and then we'll just say quiz ID here. You know, does not exist. And then when we now go to call this, we'll get, oops, something bombed out. Oh, it's because I have the single quiz response. Like, I love live demos. Quiz, give me 1 second. Oh, my bad. It's because I returned it. I meant to raise the exception. So, oops. All right, there you go. Now you can see the error message came back as a 400 with that error message. Cool. So that's pretty much everything I wanted to go through and talk about. I have a bunch of links here just to the docs. I'll share the slide deck afterwards. I really like this this Bootstrap with Vue. It's basically like a project starter that gives you an entire full stack app with a Vue front end, like a FastAPI backend, and set up with Postgres, and gives you all these like Postgres management tools and everything, and like all set up, ready to go. So if that's something you're interested in, take a look. It's pretty cool. But yeah, that's it. If there's any questions, I'll be around for a little while to answer them. So thanks, guys.
Thank you.
No problem.
Thank you.
And I'll make sure to share the slide deck tonight as well.
Sorry, did you say a slide went out last night?
It was a just a Google Doc with just like a setup guide for.
Is it for everybody that was registered for this session?
No, I actually sent it out just in the Hackathon at Home channel.
Okay.
It should be pinned. I think it's the most recently pinned one. So if you want to follow along with that, it should give you have everything set up for you once you.
Awesome. Thank you.
Yeah, no problem. Cool.
Are we all set, Liam?
Yeah, I think we're all set. Seems like there's no more questions. So, cool. Thanks everyone.
Great,
Appreciate it.
thanks. And we'll announce the person who gets the $50 gift card in just a moment. Thanks, Liam, so much for the workshop, and thanks everyone for attending.
Cool. All right. Take care, guys.
Bye, guys.